In the spring of 2021, if you flew a drone over certain fields in Kentucky, you'd have seen something strange. Thousands of brand new pickup trucks, finished, painted, parked in grass because none of them could be actually sold. Each truck was missing one single component, not the engine, not the steel, a part smaller than a postage stamp that costs a few dollars and that no amount of money could actually buy because the world had essentially ran out of it. That part has a name, and once you understand it, you will never look at the world the same way again. This is the most strategically important object on Earth. Governments now fight over it the way they used to once fight over oil, and almost nobody can explain what it actually does. Strip away the acronym and every acronym that's actually attached to this one particular term, and a chip is one idea repeated to an absurd degree. A switch, on or off, 1 or 0. Flip switches is the right pattern, and they can add numbers. They can add numbers fast enough, and they can show a photograph, steer a plane, recognize a face. Everything a computer has ever done is switches flipping. In 1947, a Bell Lab in New Jersey had three physicists who went on to build the first electronic switch with no moving parts, the transistor. It sat in the palm of a hand and looked like a science fair project, a wedge of metal, some wire, and a paperclip. Today, we make that particular switch so small that the newest chips carry over 100 billion of them in the space of your fingernail. If each transistor were a grain of sand, one chip would actually go on to hold a beach. It begins with silicon, refined from ordinary quartz until it is 99.999999999% pure. Nine nines, grown into a single flawless crystal, then sliced into mirror discs called wafers, so flat that if you stretched one across an entire country, the tallest bump would stand a few millimeters high. The wafers enter a clean room, air filtered thousands of times cleaner than a hospital operating theater. Because at this scale, a speck of dust is not dirt, it's a boulder dropped on a particular city. Then comes the step that borders on the unreasonable, printing circuits. The features are now so small that ordinary visible light is actually too flat to draw them, like signing your name with a paint roller. So engineers actually went on to build a new kind of light, extremely ultraviolet. A laser strikes falling droplets of molten tin, 50,000 droplets every single second to be precise, vaporizing each one of them into plasma hotter than the surface of the sun. That plasma flashes EUV light, caught and focused by mirrors so smooth that to seal the size of Germany, their largest flaw would actually be under a millimeter. All of it explains one number: a single advanced chip factory, a fab, now costs $20 billion or more. Only a handful of buildings on Earth can actually go on to do this. The machine that makes that light come exactly from one place, a quiet campus in Dutch countryside, run by a company most people have probably never heard of, ASML. ASML is not the best manufacturer of EUV lithography machines. It is the only one. Each machine weighs about 180 tons and ships in roughly 40 freight containers. It contains hundreds of thousands of parts from thousands of specialized suppliers across Europe, the United States of America, and Japan. The standard model costs over $200 million. The newest generation, which is called the High NA, runs closer to 400 million. And ASML builds only about a dozen of machines every single year. And no nation can simply copy it. Not China, not America, because an EUV machine is not one invention. It is 30 years of accumulated engineering layered like geographical strata, German mirror makers, laser physicists, software, supply chains, and you can go on to steal the blueprint, but you cannot steal these 3 decades of deep research and precise engineering. Follow that departing shipment across the ocean. It lands on a small island 100 miles off the coast of China. In 1987, an engineer named Maurice Chang founded a company on an idea that the industry thought was actually backwards, and it would design nothing. It would only manufacture for anyone who paid. That company is now called the TSMC. And the backwards idea won. Apple doesn't build its own chips, neither does Nvidia, AMD, or Qualcomm. They design and TSMC actually builds them. Today, it manufactures roughly 90% of the world's most advanced chips. The ones training AI, running your phones, guiding precision weapons, 90% on an island that a neighboring superpower officially claims as its own territory. If those fabs went quiet, a blockade, a war, an earthquake, the failure would come in order. First, no new AI systems can be trained. Then, phone and car production stalls worldwide, just like 2021, but without an end. Then, data centers can't replace failing hardware. Then the weapon pipelines of every modern military begins to starve. Some call this Taiwan's silicon shield. The world can't afford to let anything happen to it. Others call it the most dangerous single point of failure on planet Earth. Which is why a new kind of Cold War is actually underway. Fought not over territory, not over transistors, every major power has reached the same conclusion and each is pursuing some of one of these three strategies. Number 1. Restrict. In October 2022, the United States banned exports of advanced chips and chip making equipment to China and pressurized the Netherlands and Japan to follow the same principle. ASML's most advanced machines cannot be sold there. The rules have actually gone to shift since then, and by 2026, some mid-tier AI chips can flow under case by case licenses and tariffs, but the leading edge remain walled off. Number 2, subsidize. China has answered with hundreds of billions in state investment to build its own industry at any given cost. America passed the CHIPS Act, $39 billion in manufacturing incentives. Nearly all of it is now committed. Japan is actually bankrolling a 2 nanometer national champion. Korea, Europe, and India are playing and trying to keep up the pace with all of the developments that I just went on to discuss. The last one, relocate. TSMC now runs a fab in Arizona. Samsung builds in Texas. New plants are rising in Japan, Germany, and India. An attempt to move pieces of the island monopoly onto safer ground so tomorrow, in case of an invasion or any other geopolitical tension, the world is not going to stall. Because this stopped being about consumer electronics, advanced chip train AI, guide missiles, run satellites, and cyber operations. Whosoever leads in chip leads in everything downstreams of chip, and increasingly everything is actually the downstream of chips. And the race is not settling to a stable rivalry, it's actually compounding. Every technology now arriving, artificial intelligence, robotics, autonomous weapons, quantum computing, is hungrier for computation than the wave that it actually saw before it. A single frontier AI model consumed more chips in training than entire industries used to consume a decade ago. The demand curve isn't flattening, it's going vertical. Which brings us back to those trucks in Kentucky's grass that were missing a few chips for a few months in one industry, and it cost the world hundreds of billions of dollars. Now, scale that up to every industry indefinitely. The great powers of the last century measured their strength in territories and fleets and in barrels of oil. The territory being fought over now is a few nanometers wide. And the nations that understand this first won't just build the future, they'll decide who gets one.